Water pollution is the tainting of water with objects that may be harmful to humans. Unpopular to common belief, water pollution has been around for a long time due to erosion. The problem with it now is that it is on the rise, and dramatically. Due to industrial production, many waters have been proven harmful to drink and even just be in. There are movements to stop this, like the Clean Water Act, but it is still a common problem. First, 1 gram of solid lead was measured out to react with the 5 milliliters of nitric acid. The product of this was lead nitrate and hydrogen gas. To test for the hydrogen gas, a splint was lit, then put into the test tube to hear a popping sound. After this initial reaction, 3 milliliters of sodium iodide was dropped into the lead nitrate solution. The product of this was hoped to be lead iodide and sodium nitrate. If lead iodide is present, there will be a yellow precipitate. This is the stoichiometry to find the theoretical yield of lead nitrate in this reaction. As you can see, the theoretical yield is 1.60 grams of lead nitrate. The concept of stoichiometry was not known at the time, so there is no masses taken for the nitric acid or the products of this reaction. So there is no percent yield available. What I have here is lead. Lead is a metal gray, shiny as a solid. The lead is usually found in a 2+ ion, and lead as a solid is poisonous to humans. And also lead as a 2+ ion is poisonous to humans. If lead is in the water supply, it can harm animals and humans alike.
This is nitric acid. That's the chemical formula of HNO3. At high concentrations, this decomposes by itself to form a yellow liquid, but at low concentrations it is used for wood finishing. This is a highly corrosive acid and it is toxic.
We're sanding the lead right now with sandpaper so that the oxide layer from the lead goes away. So we'll have a better reaction with the nitric acid. Luke is putting 1 gram of lead into our test tube. Now he's putting 5 milliliters of nitric acid into the test tube. Right now he has the splint ready, and if he puts the splint inside the test tube, there will be a pop sound if hydrogen gas is being formed.
We were puzzled to why this didn't work. We thought we had done something wrong. In fact, what had happened is that since lead is only slightly higher than hydrogen on the activity series, it takes a while to react. Since we didn't know all this information at the time, we thought to change the masses we used to 0.8 grams of lead. This is the stoichiometry for the new mass of lead. As you can see, there is only 0.80 grams of lead used. The theoretical mass should be 1.3 grams of lead nitrate at the end of this reaction. Add the lead to the test tube. You now add the nitric acid, 5 milliliters of nitric acid to the test tube. The lead was only 0.8 grams. You will now let it splint to check for hydrogen gas. To test for lead ions in the solution, we will add the sodium iodide. If there are lead ions, then a yellow precipitate will form. As you can see, there is a yellow precipitate, so we have successfully done the reaction and have gotten a yellow precipitate of lead iodide. One of our products was lead nitrate. The lead is in the 2+ ion, so it is harmful to humans if digested. This ion is usually tested for by using an iodide because it makes a yellow precipitate. An example of the lead 2+ ion being harmful is in lead paint as a lead chromate. Lead paint was found in Mattel toys, which is very dangerous and may even cause death. So you're wondering, how can lead mix with nitric acid in the first place? One possibility is that lead ore mixes with rocket fuel, which contains nitric acid. Wood finishings also contain nitric acid. Hong Kong has a problem with lead in their water supply, not from the 2+ ion, but from solid lead from the lead pipes. It is not harmful in small amounts, but don't drink too much of it. So, reflecting back on the project, there are some things that went wrong, but most things went our way. One problem stemmed from just not knowing material. This was the problem with stoichiometry, as discussed before. We could have changed this by asking what we needed to calculate this stoichiometry, but we didn't, and in return, do not have all the parts of our project completed. An example of a good thing, which may be surprising, is not knowing why the splint didn't pop. This was good because it really made us understand that it takes time for reactions to occur, due to various reasons, this one being lead not much higher than hydrogen on the activity series. All in all, this project went very well and really helped us understand the concepts behind water pollution at a molecular level.